Hello everyone, welcome back to my presentation on sampling and inference. Let's start with a basic and important concept, which is population, also known as the universe. Population refers to the complete collection of all individuals, items or observations that we are interested in studying. Now, if we collect data from every single unit of population, this is called an census inquiry. While it gives us very accurate and complete information, it is often costly, time consuming, and sometimes not practical. So instead, researchers usually work with a sample which is a smaller subset of population. The process of selecting this subset is called sampling, and the method used is known as a sampling technique. There are two main types of sampling: random sampling, where every unit has an equal chance of being selected, and non-random sampling, where selection depends on judgment or convenience. Now let's move to statistical inference. Statistical inference is the process of using sample data to draw conclusions about the entire population. However, since we are not studying the whole population, there is always some error involved. This brings us to sampling error, which is the difference between the sample result and the true population value. This happens because we are only observing a part of the population. Also, different samples from the same population may give different results. This is known as sampling variability, and studying it helps us understand how reliable our results are. There are several key considerations in sample design. Now we discuss sample design and population characteristics. A sample design is simply a plan for how we will select our sample before collecting data. A good design ensures that our results are reliable and suitable for the research. There are several key considerations in sample design. First is the type of population. It can be very finite, like the number of workers in a factory, or infinite, like listeners of a radio program. Second, it is the sampling unit, which is the basic element selected. It could be an individual, a household, or even a geographical area like a village or district. Another important concept is sampling frame. This is a complete list of all units in the population. A good sampling frame should be accurate, complete, and representative. Then we have the size of sample. It should be too large or too small. It should be optimal. The size depends on factors like population, size, variability, and research tool. Now we talk about parameters of interest. These are the characteristics of the population that we want to measure, such as average income or average years of education. Since we usually work with samples, these population values are unknown and must be estimated using sample data. Okay, now let's understand systematic bias, which is very important. Systematic bias occurs when there are errors in the sampling process that cannot be reduced even if we increase the sample size. There are several causes of systematic bias. Inappropriate sampling frame, when the list does not represent the population properly. Defective measuring devices like biased questionnaires or faulty tools. Non-response, when selected individuals do not respond. Spotlight effect, when people change behavior because they know they are being observed. And natural bias, when respondents give incorrect answer due to personal or social reasons. There are several types of non-random sampling. First is judgment sampling, where the researcher selects participants based on their own knowledge or expertise. Second is convenience sampling, where we choose people who are easiest to reach, like students in a classroom or people in a shopping mall. Third is purposive sampling, where participants are selected because they fit a specific purpose of the study. Then we have quota sampling, where the population is divided into groups and a fixed number of respondents are selected from each group. Next is heterogeneity sampling, which includes people with diverse characteristics to capture a wide range of opinions. Finally, there is a snowball sampling, which is used when the population is hard to find. In this method, estimating participants help identify new participants and sample grows gradually. So this is all about the basic of sampling and different types of random sampling. In the next part, we'll continue with random or probability sampling method. Thank you.